how we've gone about, one, pricing drugs, and how we've gone about paying for them. My own view is that, first of all, we should only pay for drugs that work. And I don't mean that abstractly. I don't mean because it's been approved, because it was in a positive clinical trial. I mean, in each individual that takes a drug, such as we're talking about, I think they should only pay if it works. And in fact, one way to do this is, instead of paying by carrying insurance, is that, imagine this. Imagine you're, in the case I'm talking about, you're diagnosed with a cancer that could be potentially cured with this immunotherapy. So instead of asking, well, has the insurance industry, covered this, what you can imagine is the individual starts paying an annuity. And if it doesn't work, they don't pay, right? Because it's an annuity. I mean, and we're talking about cancer, where these are fatal diseases, and in fact, especially the people we're talking about. And that if it results in a long life, well, that person will pay an annuity for a long time. There could be a whole different insurance structure to reinsure that. But I think one of the biggest problems we have about the cost of medicine is how much stuff that doesn't work we pay for. And we don't have a mechanism to link what we pay for the value of the outcome. We do it for consumer devices, for all sorts of things, but we don't for medicine. And so I think one thing is to readjust whether we are getting value first. And once you've established you're getting value, then one can negotiate price. The other aspect of that is to make sure that the cost of creating the drug, the cost of creating or producing that drug, is what's in that price. Currently, the vast majority of the costs that are calculated behind the price of a drug is not the cost of either developing or making that drug, but the cost of the unbelievable rate of failures of making all drugs. And honestly, I mean, I've spent a lot of time advising the pharmaceutical industry, and for me, the pharmaceutical industry, most of the failures are incredibly predictable. Incredibly predictable. And that's a big, long discussion why. But, with this immunotherapy, once we actually figured it out, we don't make these drugs and they fail. Now, there'll be some, but there's very little cost to that. So I think we've gotten used to a system whose pricing and everything is based upon an inefficiency, a lack of success that, is I think needs to be unacceptable. I understand why it's been really hard. The science has been there. The motivation to try to make drugs for people is spectacular. But the system just, on a scientific level, has been so profoundly flawed. And that's what goes into, it's those two things. It's paying for interventions that actually don't work in the person that you've given it to. That's not a good deal. And the fact that the cost of failure is built into the cost of success. And I think we need to figure out how to move away from that. And I actually really think that there's every reason to believe that we're moving more and more, at least in certain diseases, to a much higher probability of success. So I think that's how we're going to have to deal with pricing.
Thank you. One final question.
I have a question also. So the first solution that you described that you're doing in Juno seems to be very personalized or fitting to specific people. So my question is, how does it scale?
So the question was, the immunotherapy sounds very personalized. And so how would it scale? And it turns out it's not personalized at all. Well, yes, it is a little bit. We have to take out each person's cells, but we're getting really good at that. I mean, it's really, and as we get better and better, we'll have to take out fewer cells, and that ultimately can be pretty simple. But the actual drug that you put into their cells is the same for everyone that has the same leukemia. So you're personalized in the sense that you have to take out their own cells to put them back. Now, by the way, there's every reason to believe, using stem cells and things like that, that we ought to be able to create universal donor cells, so you don't have to take from every individual. But even if you have to take from every individual, we think it's scalable.
Thank you. So we will have to stop here, unfortunately. We will have a brief meet and greet down.